Welcome to a new era of home building, where we explore sustainable home building, high-performance design, innovative offsite construction, and groundbreaking practices that are transforming the home building industry. This podcast is produced by Unity Homes, a brand of Bensonwood. And welcome to our very first podcast episode. I'm your host, Alison, Keay, sales lead at Unity Homes, and I've been in the building science and sustainable architecture realm for about 14 years. And I've been with Bensonwood for about 8 years.
And I'm your co-host, Mark Hertzler, director of Unity Homes. I've been in home building for a little over 25 years, which I think means I must have started when I was 10. But anyway, I've been with Unity Homes for a little over 6 years.
So today we're going to talk about the purpose of this podcast and what is a new era of home building. What do we mean by that? And high performance and offsite construction is where we think the future is going. So let's start by talking about energy efficiency. Insulation is the first thing that comes to mind. Superior insulation in the walls, roofs, and floors that is going to minimize heat loss and heat gain.
I think the important thing to remember is it's about managing the movement of air, heat, and moisture. And however you accomplish that, as long as you're managing that, then you're well on your way to energy efficiency and a comfortable indoor environment.
And that also plays into the home acting as a system. So this is very important for high performance homes. Wood-based assemblies that react to the environment in similar ways, like with the Unity Homes assembly. And up here in the northeast where we're located, the insulation is most commonly designed to dry to the outside. And in other climates, it is different. And the next thing that is also talked a lot about with energy efficiency is air tightness. So air tightness details in new construction have come a long way. They can go a lot further, and offsite construction is one of the things that can have those extra air tightness details that really have the home working as a system really well. Windows and doors is another thing to touch on. High performance windows and doors are going to reduce the heat transfer and radiant temperatures and improve the air tightness. And this usually means triple pane windows.
And the great thing about the triple pane windows, not only is it reducing the heat transfer, but as you mentioned, it's the surface temperature. So if you're talking about comfort inside, if that inside pane of the window is closer in temperature to the air temperature, then it's not going to feel cold. And that's really one of the advantages of triple pane windows over double pane windows is that inside surface temperature.
And we see the newer designs having more glazing where that becomes even more important. And smaller, more efficient designs mean that you're going to be closer to a window no matter where you are in that floor plan too. So windows can play an important role in comfort. We also have HVAC systems. So we're with high performance, we're looking at advanced heating, ventilation, and air conditioning, which is what HVAC stands for. Those systems are going to be more efficient and provide better indoor air quality as well, which all results in lower energy costs.
And the most common heating and cooling system that are in high performance houses now are air source heat pumps. And air source heat pumps have a low electrical load. They're very efficient. And the technology has improved significantly over the last 10 or 15 years, and they can operate in very cold climates now. And keeping that electrical load low is important if you're going to go net zero, all electric. Keeps your PV system as small as possible and allows you to have lower upfront costs in that area. When we talk about net zero, what we're really talking about is net zero energy, meaning you're getting the house with renewable energy to the point where you're producing as much energy as you're using over the course of a year. And so that's the goal of net zero energy, is to be able to produce as much electricity as you are using.
Yeah, I'll also mention HRVs and ERVs.
Can you explain to everyone the difference between an HRV and an ERV and what that means?
Yes. So I'll start with an HRV. So HRV is heat recovery ventilator. And essentially, this is a mechanical ventilation system that has a core that has a heat exchange core. So it'll actually transfer the temperature of the outgoing air to the incoming air, saving energy on not having to condition that incoming air. but the airstreams themselves don't pass each other. So it's keeping those airstreams separate, but transferring that energy in that core for your ventilation. And an ERV is energy recovery ventilator. And so that's going to be doing essentially the same thing, but it does have an element where humidity and moisture are able to be transferred a little bit as well.
And in the northern climates, we typically recommend an HRV, correct?
Right, where the humidity exchange is less necessary. Yep. So given the air tightness of most high performance homes, they're going to be required by code, but they're a great addition to an HVAC system just for the indoor air quality benefits.
And that's one of the most common questions we get when we're explaining high performance and airtight houses to people. As soon as you explain that we're making the house as airtight as possible, they ask, well, how do you deal with breathing and fresh air? And as you just mentioned, it's through that HRV, that mechanical ventilation is really what makes sure that the indoor air quality is where it needs to be.
Another aspect would be lighting, and this kind of seems like a no-brainer nowadays, but LED lighting it has significant lower energy loads than even the CFLs that we see still out there. And CFL means compact fluorescent lighting. A benefit to the design itself can be maximizing that natural light, so you need to lean on electrical lighting less.
Yeah, and this is where some of that automation can also play a big part. LEDs are a great fit for remote monitoring, turning them off, just making sure that you don't have lights on where they don't need to be. And so that is one aspect where sort of automation and technology can play a part in the lower electrical use of your house.
Yeah, there's some really smart lighting solutions out there.
There are.
So the next topic is sustainability. So this is talking a lot about the materials and the operational use or energy use of the home as well. So for materials, this means the use of sustainable, non-toxic, locally sourced materials. Sometimes that's recycled materials that are going to reduce environmental impact. For unity, that means wood-based materials and recycled insulation like our cellulose we use.
And we're really looking for, in sustainability, materials that are going to last a long time as well. We want this house to last, and that's one of the most sustainable things that you can do. Is if a house is not lasting and it's going to have to be torn down, there's a lot of energy that goes into that. And building a wood-based house that's going to last hundreds of years, it's storing all that carbon for all that time.
And of course, renewable energy. The integration of renewable energy systems like solar panels and wind turbines to reduce the reliance on fossil fuels. And the most common way to get to net zero is going to be the addition of solar panels on your home as well. Next, we've got durability and resilience. This is important for the overall life of the home, for the maintenance that you're putting into the home as well. And this starts with the building envelope. So construction of a durable, well-sealed building envelope that withstands weather extremes and minimizes maintenance is going to be really important. And it hinges greatly on how the systems manage moisture and if they can do that appropriately for their climate.
When it comes to the moisture management on the outside of the house, we refer to that as bulk water. Generally, it's rain. And how does that house shed the rainwater? How does it come off of the roof? How does it come off the siding? And how does that interact with the entire building? So for durability and resiliency, we want to make sure that the bulk water is managed properly and it's drained away from the house.
We also want to talk about the design. A resilient design is going to create a home that's more resilient to natural disasters like earthquakes, floods, hurricanes. And one of our houses was even recently hit by a tornado here in New Hampshire. And Mark, you visited that. Do you want to talk a little bit about it?
Yeah, interesting case study. So one of our houses was in a direct path of an EF1 tornado. And you can see all around the house, trees that were toppled, snapped in half, just an incredible force of nature, taking the screens off of the porch and wrapping them around trees about 100 yards away. In this particular house, it had some cosmetic damage, a couple of clapboards broken, some shingles that were pulled off by the wind, and a couple of windows that had debris slammed against them that were broken. But other than that cosmetic damage, the house stood. Engineering-wise, it was solid. Inside, no damage whatsoever. The homeowners, fortunately, were unfortunately, they were on their porch when the tornado hit, but fortunately, they were able to get inside before it got too bad, and they were able to ride out that tornado completely unscathed. So those things are important to think about, where you are, what your environment is around you, as Alison said, whether it's earthquakes, floods, hurricanes, or even wildfires in some areas.
Yeah, another thing that New Hampshire experiences a lot is power outages due to snow and ice storms, and resiliency and our ability to have the envelope perform in a way that actually is protecting you during times of power outages through the increased level of insulation to protect you from excessive heat and for losing power in the summer and heat loss of your home during the winter if you lose power.
Yeah, that's a good, very important point, especially in the wintertime. You lose power. If you don't have a backup source of power, you want to keep your house as warm as possible for as long as possible. So well-insulated envelope, airtight, will allow you to go much longer, keeping your house comfortable inside in those conditions.
Yep. We also have comfort and health. This has become more and more of a reason that I think people are searching out high-performance homes, and that starts with thermal comfort, so maintaining consistent indoor temperatures throughout the home, simply for comfort reasons, that you're not always chasing that sweater. And acoustic comfort is another aspect. So the high levels of insulation and the triple pane windows go into how quiet the house can be and how protected it is from noises outside of the home. You know, a lot of the time we have noisy neighbors, we have traffic or trains or things like that do our health a benefit to kind of buffer those.
For the thermal comfort, any house, you can turn your heat up high to try to get that temperature up. But it's not necessarily comfortable heat by just turning your heat up. Different types of heat are either blowing hot air for some period of time, and then the thermostat tells it to shut off, and the temperature starts dropping, and it's cold, and then comes back on, and then it blows again, and that constant fluctuation back and forth is not necessarily comfortable. And older houses, not well insulated, not very airtight, get what's called the stack effect, where all the heat will rise to the highest point. So on the upper levels, you'll be hot. The lower levels, you may be cold. So that thermal comfort really goes to that consistent feeling and temperature, throughout the house, no matter where you're going, and just trying to minimize the fluctuations.
Enhanced ventilation systems that are typically part of a high-performance home are going to ensure a constant supply of fresh air and the removal of indoor pollutants. This is especially important in areas of wildfires, families that have allergies, and can really be a factor in childhood asthma as well. So part of the indoor air quality element is reducing the pollutants that are in the home to start with. So thinking about the materials you're bringing into the home and their VOC content, thinking of the combustion appliances that you might have within the house, which is one of our major reasons for designing all electric, is to remove those. Cooking can actually be a indoor air quality issue as well, and especially when you're using a gas range or a gas stove.
You had mentioned materials with low VOC. Explain what VOCs are.
Oh, yes. So VOC stands for volatile organic compounds, and those are chemicals that are released via off-gassing from man-made materials, essentially. So it's usually coming from glues and other things that are off-gassing over time, releasing into the air. Formaldehyde is the biggest kind of culprit for poor indoor air quality and off-gassing from things like furniture, but also building materials. Cabinetry is often a good one, or not a good one. Cabinetry is often a source of VOCs, and so seeking out specific brands and materials that are low in their VOC content is important.
And some people are very sensitive to those VOCs. Other people are not necessarily sensitive in the way that they're aware, but it adds to the indoor, the low quality of the air inside, and sometimes is not necessarily noticed, but it does have an impact on your overall health, whether it's anyone who has allergies or asthma. Those sorts of things can make those worse, and removing those things can actually make their health better.
Indoor moisture control is important, and that's where the appropriate exhaust from the kitchen and the bathrooms is important. So we're designing strategies to manage the moisture and prevent things like mold growth, and ensuring a healthier indoor space for that. And that's going to rely on mechanical solutions. So the HRV or ERV are going to be a player in that. And we really are in favor of direct to the outdoors kind of exhaust in the kitchen areas as well. You want to get those indoor air pollutants and excess moisture from boiling that pot of pasta or something like that out of the house as soon as you can.
Or cooking your fish.
Oh, cooking fish. You'll need the air quality and moisture control for that. So the second part of the future of home building is offsite construction. There's different forms of offsite construction. Sometimes offsite construction can also be called just prefabrication or prefabricated construction. It can come in volumetric or modular, as it's better known. That's probably the most common, and that requires fabricating in a factory in boxes. So those are going to have at least three sides to a box. I guess it is 4 if you include the ceiling and floor and two walls at least. And so those are fabricated in that way so that they can be lifted into place by a crane, shipped on a truck, and put together on site. And those can have a greater level of finishing. So even plumbing, electrical, drywall, paint finishes even can be installed in that type of offsite fabrication.
And most of you have probably seen this, the big modular sections going down the road on a truck, and they probably had an escort with a wide load.
Yes.
So that would be the modular version.
The other type of offsite fabrication is called panelization. This is a method where the walls and roof and floor systems are built as panels, and it goes together a lot more like a gingerbread house might go together. And the flexibility of the size of the panels can vary, and they're shipped a little bit differently in that they can be shipped upright and have smaller trucks potentially shipping them. However, with panelized construction, the finishes and utilities are mostly completed on site.
And just one other differentiation. So there's sort of a third category, which is manufactured housing.
Yes.
That's a separate category. Manufactured housing is what most people would refer to as a mobile home, permanently has wheels. Modular is not the same as manufactured. Modular has floor framing, it's craned into place, and it's permanent. It is not on wheels.
Well, I'll also add the differences amongst their foundation types. So with modular, because it comes in a box and there is a floor system on every piece, there is a need to have at least a crawl space foundation. So most modular homes are going to be on a full basement or a crawl space foundation. Panelized, it does allow you to build on a slab on grade, which has multiple benefits, cost savings, amongst other things. Panelization can also have full basement and walkout basements. But the common advantage of all of these methods are that much of the work can be done in a controlled environment out of the weather while the site is being prepared. So there's some parallel processing going on.
Yeah, and that allows for a much higher level of precision in the final product. As I mentioned before, I've been in the home building industry for a little over 25 years, and I started out stick building on site, swinging a hammer. And there is some drawbacks to doing that and, measuring and cutting everything on site. So a lot of houses are built that way, but the offsite construction can allow a much higher level of precision.
So we've got what Mark just alluded to, the improved quality. So quality control in a controlled environment is much easier. Building in that factory setting allows for more control over the construction process, the material storage, and all of that leading to the higher quality, more consistent product. There's precision manufacturing that's available as well. We're using advanced tools and techniques to ensure that the components are built to tighter specifications, reducing errors and defects, and there's an actual quality control process that's overseeing that in most manufacturing environments.
Yeah, that's a good point because the offsite construction can still be, I want to say, somewhat low tech. It's in a controlled environment, but much of it is still being done the way it would be done on site. Or as Unity Homes does, we have some pretty advanced equipment that is measuring, cutting everything, assembling everything to exact dimensions. So there's a wide variety of that precision in the controlled environment.
And I think one of the most sought after value points of offsite construction is usually the faster construction time. There are processes that are happening at the same time. The site prep and building component construction in the factory can often occur simultaneously, significantly reducing the overall site time and timeline of the project. Cost savings is the next value point. So the reduced labor costs by using factory-based construction. It can be more efficient, requiring fewer workers and done in less time, which reduces the labor costs.
Yeah, and for those of you in finance, it comes down to even things like workers' comp. So when you have workers out on site in those conditions, the workers' comp rate is fairly high compared to having workers in a factory in a much more safe and controlled environment. So it's not just the actual labor that's being reduced, but the other costs that are around it that can be reduced as well.
And minimized waste. The precise manufacturing processes result in less material waste, which lowers the material costs and the environmental impact. There's also some sustainability efficiencies that are possible in a manufacturing environment that are not possible on a site-built job site. So, for example, utilizing renewable energy to power the machines that are building the offsite fabricated components, recycling and reusing the wood that is the off scraps.
With offsite construction, it does increase the overall safety, especially for the people that are producing the panels or the modules. As we had mentioned earlier, the workers' comp rate is much lower because it is a safer environment. It also allows the opportunity to use equipment to reduce the strain on the workers. So in many factories, there are things like overhead cranes, there are vacuum lifts, things that assist the people that are moving those materials around so that they're not straining themselves quite as hard. And that's just it's a safer and it's a healthier environment for the people that are doing that work.
There's also the opportunity to reduce site disruption. So we're minimizing disturbance on the site by a reduced timeline and a quieter construction period too for that framing stage. And that's a really great solution for infill projects. There's going to be less noise, dust, and disruption to the neighbors and surrounding area.
Yeah, we've gotten that comment many times from neighbors of projects that we've built where they've commented on, generally, as we mentioned before, they could be doing framing for 3-4 months. And as anybody knows, it's had a project that's gone next to their house. There's nail guns and hammers and things going on for that period of time. So when you can come in and within a few days to a couple of weeks have all that work done, it's a huge advantage to the neighbors.
Offsite fabrication also allows for scalability. With efficient production, offsite construction methods can be scaled to produce multiple homes simultaneously, making it ideal for larger developments or housing projects. And there's also repeatable quality. So the consistency of that construction can ensure that each one of those units is meeting those high standards and allows for growth in the housing industry, which we so very badly need.
Yeah, and that scalability, what that translates into for the homeowners is a lower cost. So you can get a higher quality product for a lower cost through that scalability and repeatability.
Yes, high performance has a reputation for being more expensive. It is delivering more than the standard code, so that makes sense. But offsite construction is the path to lowering those costs for high performance specifically as well.
That's right. And that's really the goal that we're working towards is everybody should be living in a high performance home that is comfortable and healthy.
Thanks for listening to our very first episode of a new era of home building. If you're passionate about high-performance homes like we are, be sure to subscribe to our podcast and stay tuned for our next episode on the basics of offsite construction with guest Jay Lepley of Bensonwood. You won't want to miss it. You can also visit unityhomes.com to learn more about our upcoming events, subscribe to our newsletter, check out our home plans, and get in touch. Thanks to George Peavy, Jason Reamer, and Josh Reamer of our company's very own Plum Gable Band for the music you hear on this podcast. And thanks to Damaris Graham for the production and editing of the podcast. We hope you enjoyed this episode. Until next time, I'm Alison Keay.
And I'm Mark Hertzler.
And here's to better building.